I think we probably ought to do a round of introductions before we get too far into it. So I'm Tom Akehurst. I'm the CTO of WireMock. If you don't know us, we make an API simulation tool, and so hopefully our interest in the concept of environments is fairly obvious. Let's go around everybody else and introduce, and then we'll kind of set the scene for the panel. So, how about we go with Michael first?
Sure. So I'm Michael Irwin. I'm at Docker. I think everybody knows what Docker does at this point, so I won't explain Docker. But I'm a principal engineer at with our developer success team, and so do a lot of enablement and training materials and helping folks get up and going with Docker and now AI and all that kind of stuff as well too. And been in the Docker community for just over a decade now, so it's been fun to see all the changes and we'll talk about some of those upcoming changes as well. So excited to be here.
Okay, should we go Justin next?
Hey folks, Justin McCarthy, co-founder and CTO at StrongDM. We are a cybersecurity company that deals with identity, access management, privileged access, all those topics. And recently been substantially focused on the concept of software factories in the presence of an application of obviously what the LLM models are capable of here in 2026. So that's me.
Awesome. So I'll go next. My name is Waldemar, CTO and co-founder of LocalStack. For those of you who don't know us, we are basically building a local cloud development experience. So the flagship product that we put out there is an AWS emulator that runs fully in a local machine, has something like, I think, 110 AWS APIs supported at this point. So it's very high fidelity emulation that we provide in this container. Yeah, it all started as an open source project many years ago, and now for the last couple of years, we've also built a team and a company behind LocalStack. And this is a topic that's very close to my heart, right? You know, sandboxes and the age of agents. So super excited about the conversation today.
Great, thank you all for being here. So just to kind of set the scene for the panel, I think broadly we're talking about sort of environments and the sort of relevance and future of environments in the kind of software building environment we find ourselves in. I guess the key thing, but what I've observed about the concept of environments is a very old one. Pre-production environments for developing and testing software before we ship it to production. I think we're all familiar with that. Our observation is that environments can be a huge bottleneck on delivery. They're hard to get right, and that was before generative AI came along. And now we have people using agents to both generate code, and we have all these new forms of kind of automated software production. And also we have people building agents as well. And I would say that we need a fairly fundamental rethink of how we build environments if we're going to really take advantage of all these new capabilities. So the first question I want to ask is, to everyone on the panel, first of all, do you agree with this observation? And if so, what changes do you think need to happen in order for us to kind of capture the value that generative AI potentially offers? I'm going to put that question to Voldemar first.
Yeah, totally. I mean, I think what we're definitely seeing in the last couple of months is definitely phenomenal and extraordinary. Right? So I think the quality explosion of these models that they can reach, close to human level, coding skills essentially is just changing the whole market upside down, inside out. The interesting part about it is that it's becoming increasingly easier to create and generate code, right, with these models. But at the same time, we're also seeing in our customer base and a widening testing and validation gap, right? So it's becoming even more critical that all this code that gets generated is actually scrutinized, tested in environments before it actually hits production. So I think that the percentage of code being generated to what actually hits production is also sort of lowering and lowering, right? Because all this code is being generated, and we need efficient, effective ways to test all this, right? And of course, I think we have our unique view to this with the sandboxing, but also sort of happy to hand it over to the rest of the group. What do you think about that recent development?
Sure, yeah. Should we go with Michael next? What are your thoughts on this?
Yeah. I mean, so one of the things I've been thinking a lot about is that in many ways, if we look back a couple years ago, we went through a similar cycle when DevOps became the thing, in which now we're wanting to deploy software faster. And what it did was it really let us kind of focus on where are the bottlenecks, where are the things that we get stuck up on. And so, of course, that's what helped out a lot with the container revolution and whatnot, of being able to just ship software faster and whatnot. But I think in many ways we're going through a lot of the same ideas of, now that we can write the code faster, and even use AI to help write our specifications and set up environments and on all these different things, it's helping. It's causing us to go back to the drawing board of like, where again are these bottlenecks, and where are the things that we need to make faster, and is this step even needed anymore, and just rethink a lot of the pipeline. And so, yeah, I think there's a good opportunity for us to reimagine and rethink some of these things, while still keeping some of the core principles that we want in mind of, okay, we want to be able to ship safely, we want to ship securely, we want to make sure that we're actually solving the problems, not just introducing more along the way.
Yeah, absolutely. So Justin, I've saved you to last. I know you've probably got the most radical take on this. You've recently written about software factories and digital twin universes. So what are your thoughts on this question?
You know, as much as sort of like the priming here has been about environments, the way it feels to me at this moment is that environments are just one aspect of the total concept of validation. And it's really the total concept of validation that I'm experiencing in the foreground, which another way of saying it, sort of in lay speech, would be, how do you know it's right? Okay. So, you could even take the sort of a Six Sigma, five whys, how do you know, right? And just like, but how do you know that? How do you know your validation is right? How do you know the thing that generated the validation is right? And as you just work on that question, how do you know it's right? How do you know it's secure? How do you know it's fast? How do you know it's durable? How do you know it's performant? As you ask all of those questions, environments play a part, but equally, the life cycle of how you're generating and actually amplifying up the data that you're going to flow through those environments. And then how you're observing the actions of the system as it moves through the data that you're flowing through the work piece in the presence of the environment. So I'll just offer that's what I'm seeing right now. I'm seeing a fairly zoomed out view of really the entire some might call it the software development lifecycle, but I think it's even zoomed out further than that. And it's the business. How are you creating a model of the total business that you can inspect, reverse time, play time forward, and then as generative code enters the environment, it's subject to all the same mechanics. Okay, so that's sort of where we're spending a lot of our time, just on the word validation in its many, many, many forms, very deep and sort of recursively in every direction.
It sounds like you're kind of implying that the sort of traditional lines that we've drawn for a long time between, like, this is an environment and this is the concept of one and this is what it does, that maybe you're questioning that. You're saying that we shouldn't be thinking in terms of those boundaries that we used to draw, and have a wider conception of it, or maybe not have a conception of environment as distinct from other things that we're doing. Is that fair, do you think?
That's how it feels. So it feels like we're solving the problem of validation. And but sometimes we might need an environment. Sometimes we might need a very extremely high fidelity replica of the AWS API, as we heard from LocalStack, right? So that actually might be the best thing to perform validation for a particular piece and a particular facet of the system. But that may have nothing to do with how you're validating, the math on another calculation, and it may have nothing to do with how you're validating the tone of the an agent interacting over Slack or something like that.
Yeah, okay. So that's you've touched on a point, something I think about a lot, which I think is a really, really I think interesting thing to examine in this context, which is about kind of simulation and fidelity. So I think in some shape or form are working with tools that are about simulating things in order to kind of change the improve the economics in some way of building an environment. And whereas I think again looking at the sort of traditional conception of how we tested software, you tried to build something that was a really high fidelity, faithful replica of your production environment. Whereas now I think we're shifting to a world where we're being very selective and thinking about like which things need to be realistic, how do we measure that, how do we design environments to be good enough for the task at hand. I don't know. Does anybody want to make any observations about that? About how we define those things and how we, those of us that are vendors, how do we offer that to our users?
Yes, great point. The thing that comes to mind is like in addition to the validation challenge, it's just the experimentation that is becoming so much more feasible now at scale, right? So, there's even these stories out there of folks who are creating like virtual companies that only optimize for the target function of like make 1 million of revenue and just try and figure it out. Those are your tools, and you just either create a website or you do some trading or whatever it is, just make money, and then it's almost like being able to create parallel universes that of your existing maybe software stack, and then experimenting. Okay, what is I could change something here or something there, and then really see what the impact and the outcome is going to be of a change at large across your code base and the application. So I think those are things that are just have been absolutely impractical a year ago, and today and in the future they're here. And again, to tie it back to the environments, like experimentation always needs, something, an environment to run in, right? And it's ideally some kind of copy or replica of your actual thing. And that's again, we're kind of closing the loop with the emulators and containers and all the different stories that come to play here. But experimentation is huge. This is to me like one of the biggest, factors that change the industry as we speak.
Yeah, I'll jump in a little bit as well too. One of the things that comes to mind as well is, of course, the AI that we have today is the dumbest it's going to be going forward. It's only going to continue to get better, have more context, more ability to understand things. In my own experience, when I'm writing software, it does really, really well when I've got clearly defined boundaries. I've got my code base. It's not too complex of a system, et cetera. And so in many ways, it's also getting me thinking back to, the shift that a lot of folks were making from these huge monolithic things that are hard for even teams and humans to understand to microservices that are, again, have clear boundaries, are clearly testable. I can have integration tests. I can test the boundaries around them. And I think in many ways, the teams that are adopting AI the quickest, the easiest, the fastest are the ones that have a lot of these architectures, maybe not full on microservice systems, but have clear boundaries of how does this system interact with this other system. Because again, if it's hard for a human to pick up and understand it, how are we going to provide that with the context that others are going to understand, or the agents are going to understand? And so the teams that are adopting these practices and kind of almost been keeping up with modern practices. I put modern air quotes because it's always changing. It's proving to be a lot easier for them to adopt even these agentic development, where those that may be still a couple steps behind, they're having to make a couple of adjustments in order to be able to get to the full advantages that a lot of the agentic systems are going to provide them.
Yeah, there seems to be kind of renaissance happening, isn't there, for tools that make your rules about how you do things explicit, and and your quality rules explicit, and all that kind of thing, in a way that we all kind of knew we were supposed to be doing for other human beings, but now there's this kind of 100x incentive for doing it when you've got machines looking at those things. I think the interesting thing is about there are things that we probably never learned to describe very well. I mean, again, this thing about sort of levels of fidelity in an environment, how accurately we simulate something. One of the things I think about a lot is that's a kind of tacit understanding that developers have at the moment, for the most part. You know your software, and you kind of know what you need to build in order to build a trustworthy test. But codifying that kind of, saying, I can hand this off to a machine and reliably have it automate that is I think still a problem that's got some, a way to go before it's solved. So let me move on to the next thing I wanted to talk about, which is about kind of levels of automation. I mean, I think we probably have a spread of opinions about whether and how quickly we'll get to a world where we have sort of fully autonomous software production. Um, I guess I want to ask about like what are our kind of predictions about when and how that will happen, and also what do you think are the sort of necessary preconditions to be able to do that safely? I'll start with Justin on this one because again I think the things he's been writing recently have a lot of relevance to this.
I don't have I don't have many timeline opinions on how quickly things are going to arrive, other than fast and changing rapidly. How about that? But the way you just characterized it, fully autonomous software, I also personally wouldn't spend a lot of time even defining that, because really what we're trying to do is not have software. We're trying to have businesses, or we're trying to have science, or we're trying to have processes that work well in the real world. Okay, and so the way I am thinking about it is like, I want more of that. And what is the minimum amount I need to specify to get more of that reliably, right? And actually, we have a gradient of reliability needs also, right? Scheduling a meeting at home, making an appointment or something like that. It's disappointing when the meeting doesn't get scheduled correctly, but it's not quite the same as a life safety application, right? Structural engineering calculation and so on. So really, what's the cheapest and fastest way to get to enough confidence and enough nines on every given business process so that we can do 10 times more of it? And I think that answer goes in every direction. It ties in with what we used to call product management. It ties in what we used to call strategy for the business. So really, all of that is in play. But we for sure know that there's more to do in every direction. There's more to do in science. There's more to do in all kinds of commerce. There are more things to make for people. More people need air conditioners. There's just a lot of work to do, and reducing the time it takes to do really every part of the process is going to lead us on the path to more.
So I feel like again you've told me that my framing is wrong and I need to blow it away and think more.
Sorry, it's not a tactic.
No, I know. No, this is why we wanted to have you here. This is good stuff. Voldemar, do you want to provide some input into that?
Yeah, I mean, the thing that's just absolutely mind-blowing, and I think almost any organization is probably going through a similar transition right now, is that all our processes in software engineering have been built around humans over the last decades, right? So everything with prioritization, planning, code review, coaching, mentoring, like everything sort of has a human aspect to it. And now suddenly overnight, quote unquote, we need to adjust a lot of these processes to agentic coding and for the agents. I would challenge a little bit Justin's point. I think, yes, we can sort of move higher up the value chain in a sense and focus on business problems. I would still make a distinction between maybe software and code, right? I think the code is becoming increasingly cheap, almost asymptotically free in a sense, but we still need software that has a level of ownership where somebody needs to write the specs, somebody needs to have a certain overview of the entire complexity of the whole system. So in that sense, at least in the current iteration that we're in, certainly throughout 2026, so it's hard to make any predictions, but I think software per se is not going away and the ownership in the engineering around it, but code itself is increasingly becoming, you can almost say, ephemeral, right? It's a bit similar to the early days of immutable infrastructure, where it was a crazy idea initially to spin up a server, and then once it's been changed, it was tainted and kind of you spin up a new instance. And that similar is going to happen maybe also with code, right? So code is going to be much quicker replaced, refactored, rewritten. But again, I think that the whole complexity around it, software still needs to be driven and owned by humans, at least in the foreseeable future. I hope. We'll see. What's your take, Michael?
Yeah, that's a good question, and I think we that's the $1 million question, and I think we're all still trying to figure out the answer to it. One of the thoughts that's coming to mind as well too is Justin was talking about at the end of the day we're trying to help businesses and whatnot. I spoke at a local technology council about a year ago now, just on AI and how it works and all that kind of stuff. And it was definitely a technical one. Here's how the models and tool calling and definitely behind the scenes of it. And I had a woman come up to me afterwards who said, I probably understood maybe 10% of what you talked about. And I was like, okay, tell me more. And she said, yeah, I'm just a small business owner. And I'm trying to find ways that I can use AI to enhance my processes and the things that I'm doing within my business. I'd love to have small apps that help me manage my calendar or to help me manage my inventory or all these different things. And she's like, I'm not a developer, but there's got to be a way that I can do this. And a year ago, okay, I don't think the coding agents were quite at that point yet, and see how much things have changed in the past year. Now I can go back to her and just say, great, here's now you can write the apps and whatnot. And kind of as Justin was saying, like her reliability and is she creating life safety systems? No, is it the things that she might need is going to look very different than what agentic development for, again, a life safety system is going to look quite a bit different. And so how do we support all these different needs and what is the right thing? And again, a year ago, I probably wouldn't have trusted my AI with writing a lot of the code. And now I write very little. And so it's hard to predict what things are even going to look like a year from now. But I anticipate that, yeah, the shift is going to be very much that way of what is the intent? What is the intent of the software that I'm trying to write? What are the business needs, the customer value? Why does this thing even exist in the first place? And then kind of taking a step back and letting the agents and other tooling actually write the software. I think we're not far off from that, but again, it's hard to predict timelines when we're in this space because again,
maybe it's a case of there is no there to get
yeah.
to. That what happens is that the sort of the level of abstraction at which you have humans intervening kind of just goes up and up and up as time goes on.
Yeah.
Absolutely. I think it may be the feature that Justin's describing where it's almost like you're stating very high level business needs and allowing the machines to take care of it, and whether that means writing software or operating systems or in some ways directing human beings even to do jobs. Maybe there's a sort of a broader picture whereby you're automating your business rather than automating your software. And over the long term, our notion of kind of software and automation and so on like that will end up seeming like a kind of an artifact of a period of time rather than sort of the way we do things. Okay, so I appreciate we've kind of been very very sort of high level and philosophical so far. I'm hoping this next question will bring us down into the practical a little bit more. So I wanted to ask about your own experiences of using generative AI to automate things within your own businesses, your own sort of dog fooding experience, I suppose, with these things, and what you're doing, how you're building feedback loops, how you're validating things while taking advantage of these tools, all that kind of stuff. Should we go with Michael first this time?
Sure. Yeah. So here at Docker, of course, Docker's trying to make lots of tooling around this space to enable agentic development to be safe and secure. There's not a day that goes by almost that I don't see a post on Reddit of agent X did this thing to my machine that I didn't want it to, nuking my file system or leaking credentials or whatever else. So we're building a lot of tooling around that aspect of things of how do we kind of put the guardrails around the agents. But in order to do that, well, we ourselves have to become a AI first software development shop. And so there's been, of course, lots of efforts to go through that. We've got Slack channels and people sharing best practices, what's worked, what hasn't worked, et cetera. But it's definitely a learning curve. And I'm seeing a lot of our teams, a lot of the pull requests that are being opened. You see that it's a lot of the code is being written by AI now. And so, yeah, we're still trying to figure out exactly what all this looks like as the industry is getting there. I would say we're probably not at the point where we've got the software factories like Justin's talking about. But I would definitely say we're definitely beyond just code completion. And the agents are writing quite a bit of the things that we're doing. It is helping us move a lot faster. We're able to prototype and try things out. And okay, this didn't work. Let's try something else. So the kind of that rapid prototyping and proof of concept aspect. I'm seeing even PMs jump in and saying, "Hey, I thought about this idea, and here's a PR. Anybody want to take a look at it?" So it's kind of, as Valdemar was talking about earlier, like the ownership aspect of things has to be really well defined, because now really anybody can contribute to the projects, where before
people are talking about citizen developers a lot at the moment now.
Exactly. Yep. So we're starting to see a lot more ideas coming from everywhere in the organization, where beforehand it might have just been those that could actually write the code, which has been an interesting shift.
Yeah. Voldemar, do you want to give us your input next?
Yeah, so yeah, similar experiences on our side. So we, I think we have a traditionally very strong people-centric engineering culture that we've built over the years. But now, of course, with we're rolling out cloud code licenses to most of the team, and of course, we see acceleration actually in some of the. So there's parts of our product that are very measurable in terms of velocity and output. For example, the emulator itself, you can really measure, okay, what's the parity and coverage of the different APIs that we're implementing, right, and supporting, and that is, we already see quite a bit of an uptick there. And again, from the experimentation point of view, the other thing is it allows us to think in like bigger pictures, right? So okay, what is the today's implementation? What are some of the gaps that we see? What can that look like in half a year and a year from now? And then really think about, okay, can we set up a controlled experiment with controlled outcomes or quality gates of the emulator that we want to achieve, and then sort of let an agent do the work, even if the code itself might not never see production, but at least we can try it out. But the one thing I'm going to add is again coming back to the kind of writing code versus the quality gates. We still see that, especially on the emulator side, the human expertise is still extremely valuable for identifying the gaps. So I think AI is really good at churning out code and making sure that a test passes, but somebody needs to first write the test or the quality gates, and that is something where we're experimenting to also have that be more autonomous and agentic, but there is still a lot of human in the loop when it comes to just the guardrails of what we're building. So yeah, it's definitely a process for us, but certainly exciting to be in that space in 2026. So that's great.
I imagine what you're doing actually is very very sort of Gen AI friendly, in the sense that because you're emulating something that already exists and is therefore very well specified. That's the sort of thing that AI is particularly good at, in my experience. I mean, a lot of what we've been doing recently is around so I'm building a skill at the moment that is we'll go and look at documentation, open API documents, all of that, kind of not, sort of artifacts that describe how APIs work, and then building simulations of them, and using those, particularly the open API description as guardrails, for keeping the simulation valid. And, I think there's, that's the sort of thing. It's, having those things is very valuable. If you want to build environments that have simulated elements, then prior to Gen AI existing, you had to put the work in order to kind of transcribe, to emulate something, and often that's a lot of work that a lot of people are not willing to do. So having something that can do that grunt work for you, but having a sort of external source of validation that you can use in the form of the real thing that you're emulating, I think you can that can be a very effective use, and particularly if you're actively, the other thing I've found is a concrete practice that's very effective in this process is to, when building these simulations and it doesn't go quite right, if I find either it's struggled to build some parts of it or just got it wrong, to sort of say, write me a summary of why this didn't work, and then contribute it as to the skill text, so there's an extra bit of skill text with some advice on how to deal with this problem. And just working in that loop of like, go and build me a simulation of this API today, now tell me all the things that went wrong, and drop it in the skill, sort of progressively improving it, so that next time we try it sort of one shots it. Again, Justin, I'm sure you've I mean, I think your article did a great job of describing at a high level what you're doing, but do you want to share for those that didn't read it?
Sure. So the essence of what we're doing really in every time interval is working backwards from this validation question. How do we get a description of what we want in the business, and then working backwards from that, how can we take ourselves out of that loop to the greatest extent possible? Okay, so even the point, Tom, you just used an example of observing something that was generated, but it wasn't quite right. We don't want to see things that weren't quite right. Okay, we want to see things that every token has inspected it from every angle And as far as there's wide multi-model consensus that it is right and it is working. That's the only time we want to let our retinas perceive any report or summary or anything. Okay. So that's the image that we have in mind of what we're trying to sort of get to. And we do that through interactive and non-interactive, let's say agentic coding. And by interactive, what I mean is that's what a lot of us experience when we use something like Cloud Code, where we're essentially at a REPL and we're talking to it. That's actually useful for orchestrating, coordinating, launching research campaigns to build up sort of a tranche of your next intent. Once you have that intent, however, you're trying to pitch that over to a non-interactive. And this is where our attractor framework, which is our definition of a coding agent that doesn't have a REPL, that just sort of works, and it will grind for hours or days on a security question. It will grind for hours or days on a UI question. So we're really trying to go interactive until we've created a tranche of intent that's really a delta to the specification, a delta to the validation harness, et cetera, and then throw it to the attractor, and the attractor does the rest of the work. So that's really the loop of what we're trying to do today. And I'll just say, for all of these, the other thing that the other sort of meta loop on top of that is every time we do something by hand, every time we encounter a snag, we're really trying to 5 whys that. And 5 whys, why did I need to say that? Okay. And this is just a really, really easy test.
Mm-hmm.
Whatever you're looking at on your screen, screenshot that sucker, take the log file output or whatever, put it into Gemini, Opus, and then GPT, whichever one we've got right now, 5.2, maybe 5.3 is coming today. And then ask. And if they're all baffled, then you're at the frontier. But if the consensus of all 3 of those big brains says like, oh, your problem's right here, then Tom should not have done it.
Yeah, that's an interesting point. There's a specific question I wanted to ask you actually about. So you're in your article you described a digital twin universe. So you've been you essentially using AI to build simulations of the services that your product talks to, and obviously that we're certainly Voldemar and I build products that attempt to provide those services. You've got gone your own way and built your own. I'm curious about what the process is for essentially assuring the validity of those. How did the what you've just described, how did that play out in the case of those, so that you got to a point where you trusted those, but without having to go in and do lots of manual tinkering and inspection and verification in order to get to that level of trust?
So in the case of, and we actually have many of these now for different purposes. The original, let's say, suite of digital twin universe applications, and by the way, they're in a universe together because they actually share the same event timeline and the same state. So the users that are born into a digital twin of Okta, those users are injected over SCIM to a digital twin Slack or Teams, right? And those can OAuth as they log into Google to read some Google Sheets. Okay, so all of those realish API surfaces have a shared state in the background, which means we can view the event stream across all of these. We can rewind and replay and truncate and branch all of that. Okay, so that's why they're in a universe together, right? You could snapshot the whole universe, you could reconstitute the universe, and so on. When it came to fidelity for that particular suite, and again, we've got multiple suites for multiple purposes, but for that suite, it happened that really what we were trying to validate was fairly coarse event, let's say, coherence as agentic processes and, let's say, more deterministic processes were bouncing off those APIs. So essentially, we wanted to see that when we send the user an invite, they receive the invite after we send it. And that the invite has, the expected code and not some other code. And when they refer to something that they wrote in a Google Doc, that's there, And so it's fairly coarse grained inspection. You could almost think of it as black box QA, like what would any human observing what would they
So
point
do
to
you
and
play
say
this
that
in
is
forward against real environments as well, and then do comparisons of these timelines with
we
your
we
similar
definitely
seamless
do
timeline?
all of that. So and we
Right.
kind
Okay.
of refer to this as wall time. So we have wall time version where we're going at wall time rates against real APIs. But then we go to the hypertime version where we're doing much faster than the Octa rate limits would allow, right? And that's where we're getting into the branching universes and the replay and the swiping forward and backward. And then really the most important party that's participating in operating the DTU is, of course, not me and it's not us, it's the agents, right? So the agent's ability to then, a superior agent, see the process, see inside what happened, use that as the diagnostic, use that as the way of explaining how we got here and how we got some logically inconsistent result. Like that's the next level of profound utility from having your own copy of any given SaaS software.
This is a really interesting idea about having a timeline and being able to branch from it. I mean, I think
Mhm.
this is a theme I see emerging more and more in kind of agent focused tools.
Yeah,
Because I think this inherent ability to go, let's do some things. Well, something went wrong. Let's go back a few steps and try something else and see what happens.
yeah. And for anyone that's logging agentic trajectories, you'll find echoes of that in our CXDB, which is a small open source project that we publish, but we rely on daily for essentially seeing inside, sequences of tool calls, turns and context with provenance from multi-agent flows and all that stuff. So that has a lot of branching and replay built into it as well.
Awesome. I mean, it sounds like something we could talk about for a lot longer, actually. Maybe we need another session on that one. We do only have a few minutes left. I just I want to quickly ask a closing question for all of you, which is, uh, if if and when we enter this world where AI agents are doing doing all the technical work for us, what's the one human skill that becomes a superpower in managing these environments? I'll go with Voldemar first.
Yeah, so definitely great. Just wanted to mention to Justin's point from before. I love the idea of the user being born into the digital twin universe. I thought it was really like interesting way to frame it, and then really look at the timeline. That's a great way to think about it. Yeah, from the I think from agents versus humans. I think to me it's mostly I would say it's not a single. It's maybe I'll say it's three skills, right? So it's curiosity, product thinking, and courage. Curiosity in the sense of, okay, always challenging the status quo, right? So we can now think in bigger terms, large scale experiments. Almost nothing is impossible these days. Product thinking in terms of like switching from the sort of input focused in terms of what can we achieve as a team to, okay, what do we actually want to see as an outcome, or as a business outcome, for example, to Justin's point from before. And then the courage is just start by starting, right? Do the experimentation, run these things, because at the end of the day, somebody still needs to go there and instruct the agent to do something, like try out a new idea or start a new service, start a new business or something, right? So I think this start by starting is definitely something that becomes a human superpower, and use the tools to your advantage, and iterate from there.
Yeah, definitely agree with that. Michael, do you want to go next?
Yeah, so just for kicks, I took your question, I put it into ChatGPT to see what answer it would give.
Someone was bound to do that on this panel at some point, weren't they?
Somebody had to. And it told me judgment, but actually it's kind of similar to what I was thinking about anyways. Of at the end of the day, our agents are getting better and better at writing code, validating changes, even a lot of things that Justin was talking about. But somebody still has to own the human relationships with our customers and with those that we're actually making products for. So humans have a lot of different experiences and emotions and backgrounds and understanding. And so I think the human skill there is empathy and customer relationship, et cetera, of translating what is it that we're hearing and what is it that we actually need to build, what is it that we don't need to build, what's good enough for this particular need. And I think that's going to be something that, again, that is going to be hard to replace, at least in the short term. And then we can delegate off to the agents to help us actually do the building once we've kind of identified what is it that we need to build in the first place.
Yeah, I mean, that was pretty much what I would answer to that, I think. But I think combined with creativity as well. I mean, I think LLMs are not, they interpolate over existing knowledge. I think they're not inherently truly creative. So I think if you can take that empathy for your customers and combine it with the ability to create novel solutions out of that, then that's something that I would say we're probably not going to be delegating to the machines anytime soon. Justin, what do you think about this?
Okay, so I think the zeitgeist is pretty. It's pretty common to hear the words agency, taste, judgment. Okay, and to me, like once we all start saying something and we don't have the same definition, I kind of stop using the word. And so, so I find the models have tons of taste. I find they have tons of judgment. Okay, so those don't really resonate for me. What does resonate for me is desire. So I wake up every day and I want something to happen. I want something to progress. And the models don't. They're kind of passive. Okay. But you can recruit them to your desire. You can recruit them to brainstorm. You can recruit them to be creative. But if you don't, they'll just sit there. Okay. So really wanting something to actually happen initiates a cascade, and that initiation is then amplified by the strength of the models and how many tokens you can productively flow through them. That's it. So desire is my answer.
Great answer. Right, okay, I think we're almost at the time limit that we were going for. I think we may have a few questions to ask as well in the last minute or so.
Yeah, thanks. We are, let me just jump in. We are kind of at our time limit. So it's 45 minutes on the calendar, so we should try to stick to that. I think we've got one question that would be interesting to answer, and we'll take everything else offline. So I think there's a question about kind of guardrails, or how do you prevent, I guess, what we would call drift in kind of simulation or test environments, and who would be responsible for that?
Yeah, I think there's a couple different layers of this as well too, and I think Justin was talking about some of this as well too, with splitting out different roles and specifications and responsibilities for things, and he can certainly dig into some of that as well too. I could share, from a Docker perspective, some of the things that we're looking at is just how do you even run these things in kind of secured. I say secure in kind of air quotes because that definition keeps changing all the time. But how do we put the agents into a sandbox that they can play in? How can we observe what's going on? How can we put the proper guardrails in place? One of the demos that I run through quite a bit is I'll configure Claude Code, for example, to say, hey, you can't read this particular file. And then I'll ask it, hey, read the file. And it says, yep, I don't have permissions. Okay, now Claude, write a Python file that can read any arbitrary file and then execute it with this parameter. And look, now I can read the file. And so there's some things that are built in permission models, et cetera. But there's still ways to get around that. So how do we, again, protect ourselves from prompt injections, or especially as we're getting input from external users or just reading arbitrary GitHub issues or whatnot? What are the proper guardrails that we need in place here? So this is an area that Docker has spent a lot of time in with our new Docker sandboxes and all that stuff. I won't turn this into a product pitch, but that's an area that we're thinking a lot about of, again, how do you put the proper guardrails in place, give organizations the governance and controls that they need to be able to say, we're going to allow these tools, but not those tools, or you can talk to these network addresses, but not those, have observability throughout. So that's an area that we're looking a lot. And again, that's more runtime layer. I think there's still a lot more with how you actually instruct the agents and guide them as well.
I just want to quickly pick up on sort of the sandbox concept here. So that is, it's basically becoming the new compute fabric for agents, right? So effectively, everybody's talking about sandboxing for security reasons, for efficiency reasons, and so on. And this is, and I think we just need to acknowledge the fact that a development time agent has different requirements towards an environment than the production system has, right? So to Justin's point from before, and also Michael's point, an agent maybe wants to move fast, experiment, have a throwaway environment, fully isolated, even do things like controlling time, right? Having wall time, but also simulation time. And those are the kind of things that are now becoming more critical. And from the local stack perspective, we see that, of course, cloud providers are also putting in more, sandbox environments, but they're effectively using just an abstraction over the production infrastructure, making it easier to create a new account, for example. But we believe that sandboxes need to be fundamentally containerized. And that's why I think the story together with Docker is also so strong for us, because it is not just yet another instantiation of your fully blown production environment. It is, by definition, something that is at a different abstraction level of a sandbox. So I look forward to working more and seeing more development in that space throughout the year. Justin, what do you think?
Um, for what I would say is this is what I think of is much of what we do have historically done in machine learning, where we have the holdout and validation sets that are just, and I mentioned this in the write up, that are really a phrase we also use in testing is invariants. So there should be a very prickly set of assertions that are extremely prickly that but are all the same, almost operated by a deterministic system, like maybe traditional CI or something like that. So at no time should those very prickly cases be encountered, and you could really have that guardrail. But part of the power of this moment is to allow a lot of the rest of the let's say the trajectories through the software be automatically recorded and replayed, and have notions that are essentially infused into your product of having your users and even observers of your users really annotate like that looks good, that looks bad, and making that part of the corpus and allowing that to sort of like lace together automatically. So guardrails, deterministic, prickly, difficult but also fairly minimal, hopefully, and very application specific. But really, that's what I would seek to do.
Okay, Tom, you want to give your answer and then we'll.
Yeah, I mean, I think I've partially answered already. I mean, I think I'm probably echoing what Justin's saying. I'm a great believer in the idea of having a mixture of sort of AI-driven and non-AI-driven sources of truth and sources of validation, and that you where you can, you try and backstop yourself with sort of deterministic type approaches. I think one other observation I'd make as well is that and this is probably one of the ways in which our notion of environments needs to change going forward, is there needs to be a sort of degree of kind of forensic auditability of the environment and the thing that we're building, its impact on its environment, if we're going to do these things effectively. I think one of the other things that's not talked about so much about the way we used to do things is that we have traditionally just missed a lot of the signals that tell us how the thing is behaving. Or we have these very these quite kind of difficult and primitive ways of detecting them, and I think that's something that we need to get better at, so that we can make assertions after the fact of like, this is what happened, this is what this thing tried to do to everything around it. Was this okay or not? How do we score it in terms of it being better or worse?
Okay, yeah, I think we're kind of out of time. So yeah, I will say thank you to the panelists and thank you everyone who stuck around till the end. Look out for our email with some further resources and a recording of this session. If you'd like to learn more about WireMock Cloud, you can visit us at www.wiremock.io. You're, of course, welcome to learn more about StrongDM, LocalStack, Docker as well. And yeah, thanks again, and hope to see you next time. Bye bye.
Thanks for having us.
Thanks a
Thanks,
lot.
Al.
Bye bye.
Thanks, folks. Bye.